Have you ever thought about washing dishes? You haven't. Well, you're not thinking enough. How is it possible to find a glass in the kitchen sink? You got to look through clear air, then through clear water, then through clear glass. It's all clear. And you have no trouble just reaching in there and grabbing that glass, rinsing it off, and putting it in the drying rack. How can that be? Luckily, we have a kitchen sink here. Well, kind of. This kitchen sink is a beaker full of clear water with a beaker in it. We'll set it down here where you can get a closer look at it. And as promised, it's not hard to do. I can reach right in here, I can grab this, and I could do whatever I had to do to clean this glass. Now, why does that happen? Well, it turns out that although things are clear, which means light can pass through them, they've got properties that change the speed of light. Those properties lead to a situation where the light changes path if it doesn't cross the boundary perpendicularly. Normal angle of 0. And so we distort the image. Even though the light comes to us, we can see that there is a distortion line in one of these materials as we switch from air to glass, from glass to water, and from water back to glass. We call that difference an index of refraction. So the index of refraction is a physical property. It's kind of like density, color, weight, etc. If we switch liquids, so here we've got a different material. This is corn oil. And quite clearly, as the light goes from the air into the corn oil, it distorts. We can see the top surface. But it turns out that, like our water, we've got some glass submerged in the corn oil. A close look reveals some marks here because this is a small beaker that is in the corn oil, but all we saw was the paint. And the reason that we only saw paint is that the glass has the same index of refraction as the corn oil. And so when we put this in, you say, well, now I can see it. And the answer to that is it's full of air. And so now we're going from corn oil into glass, and I would venture to say there's no distortion. But then when we go from glass into the air inside the empty beaker, we now see it. Once we get it low enough that the corn oil goes in, boom, everything disappears but the paint. And to emphasize that point even further, hiding in the back is another beaker with no paint. And bingo, you didn't even know that was there, did you? Aha! There must be something to this index of refraction thing. And so now, once again, if we just put this in so the air remains in it, we can see the outline, not of the glass, but of the air. And the air remains visible until we fill it with corn oil, and bingo, it disappears again. And so the counterexample of, we talk about index of refraction and we give you examples where they're different from air. Air has an index of 1. But it's a big help to say, well, all right, what if they don't have a difference? And if they don't have a difference, bingo, all transparent things disappear. Wouldn't it be a nice world if you could say to your parents, I can't wash dishes because they all disappeared? You might try getting them some Pyrex dishes and filling the sink with corn oil. Or maybe it's easier to wash dishes.